Well, welcome everyone to this session of the AI Nurses Network. Today we have Dr. Julie Glanville with us, who's an independent consultant and going to talk to us about using artificial intelligence for systematic reviews. So over to you, Julie.
Thanks very much. Thank you. Thanks for this invitation to talk to you about using AI for systematic reviews. My name is Julie Glanville. I'm an independent consultant and I focus on helping people to search for research evidence. So I design strategies, I provide training in research identification, and I conduct research in information retrieval. In my previous jobs, I've been an associate director at a consultancy company, York Health Economics Consortium, where I managed the systematic reviews programme. And I've also been an associate director in an academic research centre, the Centre for Reviews and Dissemination at the University of York. In both of those jobs, I worked on systematic reviews, mostly from the perspective of research identification. I'm a co-author of the Cochrane Handbook chapter on searching for evidence, and I'm also the co-manager of a couple of information resources, the ISSG Search Filter Resource and the Sure Info Guide. So in this session today, I'm going to look at a very high level at how far AI tools can help us to develop search strategies. I'm going to look at what the evidence says and also look at what seem to be interesting developments. And I'm also going to touch upon how we can evaluate AI tools. And I'm going to close by looking at some of the resources that we can use to try and stay current in this really fast-moving area. All of the references that I mention during this course and the resources and other material that I've developed over the past year or so are all available on a small website that I've prepared, and the link to that website is there. So if you want to follow up on anything I've talked about, you'll find more information on that website. So I'm going to talk about AI tools, and that means a lot of things to a lot of people. It means different things to different people. So broadly, what I'm going to talk about today from the perspective of searching is I'm going to look at chatbots. I'm going to look at particularly at ChatGPT and Claude. I'm also going to look at what are called variously research discovery tools, which use retrieval augmented generation, and I'll talk about that later, explain that later. But I'm thinking in that respect about tools such as elicit or consensus. And then I'm going to talk about other tools that have incorporated AI components into them. So, for example, they will have used artificial intelligence from a large language models to offer additional ways of identifying the literature. So I'm going to talk about quite a wide range of AI tools, and one of the issues that we have in evidence synthesis is that AI tools can be very, very specific, tiny sort of components of our work, or they might be really quite large, deal with quite large aspects of our work when providing evidence synthesis. So today we're looking at searches to inform evidence synthesis, and just to reiterate that searches are fundamental to the conduct of systematic reviews and other evidence synthesis. It's really important for most of the systematic reviews that we undertake that the searches be as comprehensive as possible to find as many relevant studies as possible. And as well as having sensitive searches, we also need to search a range of databases and other information resources so that we are demonstrating our efforts to identify as much research as possible and to reduce the impact of the various biases that we know are present in publication. So searching needs to be sensitive and wide-ranging. And the hope is, I guess, as AI continues to develop, that AI will help us to achieve these wide-ranging and comprehensive searches. So searches at the moment are challenging for a variety of reasons, and it's hoped that AI will, in a variety of ways, will help us to make searching perhaps more straightforward in the future. I don't think we're there yet. I'll give you the heads up on that. But the fundamental idea of what we hope to benefit from AI is improvements in efficiency and retrieval. So AI has been with us now for a couple of years. Its roots have been with us for even longer. But the current AI revolution has been with us for the last 3 years or so. And lots of tools have been made available, and lots of AI has been plugged into existing tools. And already people are evaluating AI tools from the perspective of how far they can help us with the searches for systematic reviews. So we've already got available people's research and also assessments of people's research. And up to date, the reviews that have been conducted on AI tools seem to come to a fairly sort of consistent conclusion that large language model type approaches don't really perform as well as humans do in developing searches and identifying the studies that have been used in reviews that have already been published. So what large language models are not as good as us at is in identifying all of the studies that have been featured in published reviews. Recall seems to be around the 75 to 85% mark when people are using large language models, but there's clear weaknesses in terms of large language model based searching, being able to find material that's behind paywalls. So when you're searching using a large language model, you're searching large public collections usually, and what the models and the services that use large language models can't achieve is at the moment accessing databases that are subscriber only. So there's a limit to what they can retrieve because they don't have the access to the material. Also, searches are, although there are a lot of effort's been put into exploring the best way to prompt chatbots to give us the information we need, you still need at the moment, I think, to be an expert searcher to assess whether the responses being given to you are useful or not. Are the searches that are suggested by chatbots of an adequate quality to find the records, the information we need? And particularly with chatbots, there is this, in the early days, there was a really large problem with hallucinated references. This is sort of probably less the case now with the RAG tools that I'm going to talk about, but still with the chatbots, you'll probably still run the risk of hallucinations. So the reviews that have been undertaken so far have largely concluded that AI tools are helpful as a supplementary process to the traditional searches that we've undertaken to identify studies for systematic reviews. But obviously the reviews are already out of date and the technology is moving on very fast. So I wanted to sort of talk about some of the things that we can see that haven't yet been covered by reviewers. So I'm going to talk about various things. I'm going to talk about where we can find AI tools, and I'm going to look at different types of AI tools. So I'm going to look at software tools on resources like GitHub. I'm going to look at search development options using AI within some of the evidence synthesis tools that are available. So I'm going to look particularly at nested knowledge and elicit systematic review. I'm going to discuss a standalone search tool called 2D Search. I'm going to touch on commercial search discovery tools such as Scopus AI. I'm going to look at the recent developments that allow you to use Chat GPT and Claude linked to PubMed. And I'm going to look at the other alternatives that people are sort of developing, which are alternatives to the traditional search approaches we use to search databases using Boolean approaches, because there's sort of like a parallel line going on here. There's the desire to get the AI tools to replicate how we currently go about searching. So getting the tools to develop search strategies for us and to run searches in databases for us. And then in parallel with that, there are many explorations of how we can do research identification without using the Boolean approaches, or by using a combination of Boolean approaches, database searching, and other techniques. So those are the things I'm going to look at in those 6 broad groups. So I just wanted to highlight that there are lots of people developing search development tools using AI and writing programs in Python and R and putting those tools up on software repositories such as GitHub. There are all sorts of really interesting looking software, and for those of us who have programming skills, that you know how to run Python or you know how to run R, these could be really useful tools to explore and see how far they do help us with search development and with running searches. So the example I put here is Medra Agent or Medra Agent, and this is available, can be downloaded and run, and the diagram shows the components of the program, and there is also an evaluation written by the authors which I've summarized on the screen. Now, the challenge of these tools is that they could be really, really useful, but one needs the expertise to run them and evaluate them. So I don't know if MedRagent is a good tool or not, whether it works as it's claimed, but I think increasingly we're going to find that tools that might help us are there, but perhaps we need the programming skills, or we need to talk to people with the programming skills to evaluate them and tell us whether they're actually useful in a real world situation. And I do know that for many people, the security that organisations insist on quite rightly for their software setups mean that it's quite hard sometimes to download and get programs to run independent or on your own PC without permission from the software departments of your organisation. However, there could be untold riches on GitHub and similar services. I wanted to move on to some of the tools that are used for evidence synthesis, which are trying to build in the search component into the process of the whole of the evidence synthesis. So there are packages that do a lot of the systematic review process in one place, in one software package. And some of these are really developing AI-informed tools to help do the search within the package, so that you are dealing just with one package that does all of the tasks that you might need to do in a systematic review. So nested knowledge is such a package, systematic review software. It's got an inbuilt search development module called Smart Search, and this uses large language models to generate PubMed Boolean queries after you've put in in response to a plain language research question. The team at Nested Knowledge have evaluated their tool, and the recall is looking quite promising against in terms of relative recall against some Cochrane reviews and other reviews that they've looked at. But the downside of this is, although the research is really nice, it's not independent research by a team outside of Nested Knowledge. However, their research findings on the search building process in PubMed against these reviews is showing the sort of typical levels of recall that we see in lots of AI tools. So what does Smart Search do? Well, you can type in a search question in natural language and it will come back with 3 search strategies. It offers you a specific search, very focused, a middle search, and then a very sensitive search from its perspective. And you can choose which one you want it to run. It runs the results, it runs the search in PubMed and brings back records. And you can then analyze the records that are brought back from PubMed using the tools within Nested Knowledge. And this can help you to decide whether your concepts are adequate, and also to add in extra search terms and so on. So in some senses, it's a really useful tool. It looks a lot like PubMed PubReminer, which does a sort of a similar analysis of PubMed records, but it's all within the software that you would use to do the rest of the review. So there's a sort of it feels like this is the way we should be looking at evidence synthesis, where we have the search as part of the whole process. What it doesn't do, as far as I can tell at the moment, and I'm grateful for Nested Knowledge allowing me access to explore the software, but as far as I can see, it's not allowing you to do the proximity searching within PubMed. You can't really develop very complex searches at the moment, it seems to me. And it's limited in the databases that it can interact with. So it interacts with freely available services such as PubMed, clinicaltrials.gov, and OpenAlex. When adapting your strategy to run in another database, changing from PubMed to clinicaltrials.gov, for example, you have to change all the field names, and it doesn't really seem, as far as I can tell, to let you store searches. So every time you want to move to another database, you lose your strategy for the first one. So in converting from PubMed to clinicaltrials.gov, I might lose all my PubMed hard work. So there are some sort of downsides that make it a bit challenging to use. So this is just to give you a feel for what the search interface gives you after you've done a PubMed search. And what you've got here is at the top of under concepts, you've got the search concepts and the search terms that have been used in the strategy that's been run in PubMed. At the top, on the right where it says preview, it is showing you the search structure. And then in the middle, you can see some little tabs that say things like abstracts, PICO, type, location. These are all options to analyze the records that have come back from PubMed. And I've focused here on the PICO breakdown, and you can see that it's giving us the terminology that relates to the population, the intervention, and the outcomes that it has identified in the records that it's brought back from this first search. So what this allows you to do is to look down, identify additional search terms, add them to your concepts at the top, and develop the search further. So this is quite unusual in terms of its in terms of the flexibility, the ability to do the iterations. This is quite an unusual and sort of quite well developed option within evidence synthesis within an evidence synthesis package. It's still got a way to go but it is, I think, an example of how people could move forward with developing the search development process within a package. Elicit is a search tool. It's becoming more and more of a search and review tool, and they've developed a component called Elicit Systematic Review. Again, I'm grateful for Elicit to giving me access to this, because this is behind their subscription service. So this is a bit less fully featured than nested knowledge. Within the Elicit Systematic Review component, you can build and iteratively develop strategies. It offers two parallel approaches, which I can see might be a useful way forward. So it allows you to develop a keyword type search with Boolean operators that will run in PubMed, but it also offers its own semantic search as well. So what the benefit of that is that you get the benefit of two approaches to doing your searches. The keyword search takes your query and maps it onto mesh terms, and also produces text word searches as well, title and abstract searches. And you can then run the search on PubMed. You can edit the searches as well, but it doesn't seem to be very flexible in terms of allowing you to do a very complex search. It's fairly confined in what it offers you when you're trying to develop the search. But I think the issue with the Elicit systematic review options are that it still expects you to know how to construct searches and what the syntax is that's required to run this in PubMed, and it's only running the keyword search in PubMed. So there's again, this is an example, I think, of the way things could develop and need to develop further, but it's not at the moment something I think that would replace what we usually do outside of an evidence synthesis package. A tool that helps you to build search strategies just a standalone tool that helps you to build search strategies is 2D search. With 2D search, there is an option to type in a natural language query, and 2D search will develop, will offer you various ways to develop the search, and then you can move on to improving the search that it's offered you under your own steam. It's been evaluated by its developers, but so far I've not seen an independent evaluation of the tool. But if you're interested in reading about it from the perspective in a paper written by the author, written by the producers, then it is very interesting to read their evaluation. So this shows you 3 screenshots to give you a feel for how 2D search might help us with strategy development. So on the left-hand side, you can see at the top there is a question: the effects and adverse effects of green spaces or parks in cities on mental health in city dwellers. That's the question I've typed in. That's my review question. And it's come back with a series of key concepts. And what you can do is you can select the concepts that you would like it to give you keywords for. So you can see in the yellow highlighting the concepts I've chosen, such as green spaces. Once I've selected the concepts, it goes away and uses AI to find some search terms. So you can see that for cities, it's found a range of search terms, and I've looked at those and selected the ones that I think are most relevant to what I'm trying to do. So once you've selected the terms, the starter terms, you can then hit generate at the bottom, and it creates search diagrams which are based around the concepts that you've selected. So you can see I selected 5 concepts and a series of terms for each of them, and it's placed those into conceptual blocks, which you can then edit. So what you can see on the right is my editing of the concepts. I've condensed some of the concepts and I've added additional search terms. And what you can see with the urban concept is that I've started to add in PubMed tags so that I can then at the next stage run this on PubMed by selecting PubMed, and it will go away, run the search on PubMed, and I can then explore records, come back and edit this further if I want to. So it enables me in an interface that's actually quite difficult to play around with in terms of the structure of the search. It gives me a way to play around with the search structure in a much more flexible way than you can actually do within PubMed itself. 2D search has the advantage of working with a range of databases, not just PubMed. So there are other databases in other disciplines available, including electronics and education. And it also will interact with Google Scholar and other databases. So once you've put your effort into developing a strategy, you can then edit that strategy again and run it in other databases. So this seems to be, again, another way that people are using AI to help us to explore search terms and search strategy, search concepts in more flexible ways, perhaps, and helping us to get started on the search. I wanted to mention a whole group of search discovery tools that are being impacted by AI as well. So there are a range of discovery services, large database providers who are providing AI-informed aspects to their services. So for example, if you've been using Scopus or you've been using Elsevier's Clinical Key or any other large database provider, most of them now have an AI offering as well. So these are add-ons to their standard interfaces, which bring in AI options to make your searches, to help you with developing and expanding and refining your searches. Now, the issue is that obviously these tools are mostly behind paywalls, and obviously if you may be in an organization, an institution, where your library has purchased one of these and has made it available to you. So it's well worth exploring this if your organization has purchased it, and it might be that the AI options in these large database services will prove useful to you. What will help us, I think, to know about whether these tools have something worth offering is to get independent evaluations of the tools. So at the moment, because again these tools are quite new, there aren't too many published evaluations, but I wanted to point you to one by Ciule, where there's been a comparison of Scopus AI versus traditional searches for a particular literature review. So this is a case study. And also, if you're not already familiar with Aaron Tay, he's a blogger. He does lots of comparison work, and he's done some comparisons of Primo Research Assistant, Web of Science Research Assistant, and Scopus AI. So if you're at the stage of trying to decide yourself whether to go along with one of these to make the big purchase for an organization, then these types of evaluations or slightly more informal evaluations by bloggers might be helpful, giving you insights into the relative value of the different tools. I'm going to move on now to look at the use of chatbots linked closely to databases. I'm going to look at Claude and I'm going to look at ChatGPT. And I'm going to start by looking at Claude. So Claude has recently announced its option to use what it calls connectors. And it's launched connectors to PubMed, clinicaltrials.gov, and the Wiley AI Gateway. Connectors basically bring the database sort of into the Claude universe. And what this means is that you can your questions and your answers are being informed by the linkage to the database. It's possible to use Claude and the connection to PubMed, for example, with or without the deep research option. With deep research in Claude, you are getting not just the search, but you're getting the process of research selection and summarization as well. And really, from the perspective of doing the searches for systematic reviews, we're less interested in Claude's deep research option. What we're really interested in is using Claude, the connector to PubMed, to help us with developing searches and to run searches, perhaps. So I've mentioned Aaron Tay already. He's had a look at Claude with the PubMed connector, and he's suggesting that you can use it to pilot test your Boolean searches in PubMed. You can check mesh headings, you can assess recall of your search strategies, and you can use it to help refine your search strategies. So Aaron's assessments are always incredibly valuable, but obviously it's not a formal research evaluation. So I think, what we hopefully should see, what we would hope to see very soon, I guess, is people being able to conduct formal evaluations of whether Claude, with the connectors to these databases, is producing a helpful tool for developing and running searches. I've looked informally at Claude with the PubMed connector and tested it out on various searches. And I think it does do, at the moment, a reasonable job of providing a PubMed search strategy if you prompt it with some known studies, and also if you don't give it any known studies, it still does seem to do quite a reasonable job of developing a PubMed strategy. And in one case, when I tested it, it actually developed a multi-stranded search without me prompting, because it had recognized that two different approaches were needed for the particular review question. You can also use it to critique your search strategies. So I asked it to critique, I pasted in strategies and asked it to critique them against the PRESS checklist, which is the guidance, the guidelines we use when we're evaluating search strategies. The response to the PRESS checklist was mixed. It gives a very detailed assessment, but some of the comments were useful, but others were inaccurate. So I've put this example here where it suggests that using two terms linked with a proximity operator, ADG4, might be too restrictive. And then it suggests you might want to use phrases instead. And I think that sort of is just indicative of its lack of knowledge of the Ovid interface. Because proximity is less restrictive than phrases. So what it's clear to me is that we need to be good searchers to be able to decide which of the suggestions that Claude is giving to us are safe to act on. I tested it out with translations from a PubMed strategy to an Ovid Embase strategy, but that was really not saving any time. It failed to search the author keywords. It didn't know what the syntax was, and it came up with an animal exclusion algorithm that was really quite poor. So again, it's very much a PubMed centered universe where it feels safest to trust Claude with the PubMed connector. I think once you move outside of PubMed, it's going to become difficult to assess the relevance of the strategies being offered unless you are very well versed in database searching. So moving on to ChatGPT. ChatGPT has its own PubMed-specific GPT, generative pre-trained transformer. And again, you can use this to develop searches in PubMed, refine the searches based on records you found. It makes a range of suggestions for improving searches. Many of them were useful, but some were not. And it has most chatbots have a tendency to rely on phrases and to fail to recognize term redundancies. They give you too many terms and they don't tidy up the search to remove term redundancy. And again, it's not good at translating to other databases in other search interfaces. It's very PubMed focused and it just hasn't got enough information about the syntax for other database publishers. You can use it to critique a strategy, again, against the press checklist. And you can see here some screenshots of the type of response it will come back with. But you need to really know about databases and searching to be able to assess the relevance and usefulness of the comments it's providing. And what I found was that there was a mix of both useful suggestions and also incorrect suggestions. And at the bottom, I've shown an example of a suggestion it made that just won't work. So line 4 produces 0 hits in Ovid. So it's an example of both the sort of the confidence with which ChatGPT will give you suggestions that are wrong, and the fact that we need to be experts to benefit from this. So there's still a lot of room for improvement, and also quite worrying that people might try these strategies and not realize that there are problems with them. Another chatbot that I've explored is Perplexity Deep Research. So again, I asked it to produce search strategies, and it was really problematic in terms of the strategy that it said it provided. I'm not going to go through these errors, but you can see here that it was quite it performed really badly. However, when I asked it to assess a strategy against the press checklist, it did generate a useful assessment. So it was strange. The strategies it produced were full of problems, but the assessment of another strategy against the press checklist was more useful. So this was sort of quite perplexing. So now moving on, I just wanted to highlight that, as I mentioned, people are exploring alternative approaches to the traditional way we've done searching, and using AI to help them with this process. So I'm just going to talk about some of the just at a very high level about some of the approaches that I've noticed and that I'm sure people will be exploring in the future. So the first thing I wanted to talk about is citation searching. So this is using the citation relationships that papers have. So the references within a paper and then the papers that cite key papers in the papers you then cite the paper that you're interested in the future. These citation relationships have been subject to research for a long time, and researchers have published many algorithms and approaches that in turn have been evaluated. And so far, the view is that none of these algorithms would replace the traditional approach. But what we're seeing in many of the RAG discovery tools is the incorporation of some citation searching as well as other types of searching to bring back records and to make decisions about the relevance of records. So I think we're just going to see more and more of this bit of citation searching approaches being used within AI tools. We can also see the use of machine learning and machine classifiers, and this approach involves doing very broad searches where you don't spend your time on developing the search, but you spend your time on training the classifier to recognize the relevant records. And I've just put one reference here, but this is another approach that people are increasingly using, which is to devote the effort not to searching, but to getting the classifier right, so that you can just put in many thousands of records and rely on the classifier to do the retrieval. I can also see quite a lot of papers where people are doing a combination of traditional searches and AI searches. And again, I think that's whilst we're in this whilst AI is still in the evolving state in terms of being able to give us reliable searches and reliable retrieval, I think we're going to see more research where people are trying to get the best of both worlds and work out ways to combine the two processes in a way that helps to get the best out of both. And we can also see research where the AI is being used after an initial search to help to identify ways to improve the results from the traditional search. So these are just some of the things people are looking at, and I'm there's many more. There are going to be many more ways of looking at this type of research, looking at the ways that AI can be used to help us with search development. Right, I'm going to move on to retrieval augmented generation tools. These are tools that they've got various labels, but some people are calling them now deep search tools. So what these are tools that use a variety of search methods to search large public document collections. And then with most of these tools, there is the next stage of the tool after the search is that it goes through a sequence of steps, deciding on the relevance of the documents it's identified to your research question, and then writes a detailed review or summary so that you have an assessment and an overview of what the messages from the research are. Now, from the search perspective, I'm less interested in the summaries and the deep research. I'm more interested in how the retrieval is working and whether the retrieval is useful for us to help us with a systematic review. So the value of these RAG tools is probably, they're not, what the research evidence shows is that they don't perform well in terms of sensitivity. They're making too many decisions behind the scenes about relevance, so that they're providing us only with a subset of the data. But what they have value in is that they can help us by identifying relevant records which we might not be aware about, which we can then investigate to identify search terms to build the database search strategies. They offer a complementary approach, so we might do the traditional searching, but then we might also use the RAG tools to see if we can find some additional records. And they may also help us with identifying concepts relating to the research question, which may help us with structuring the search. So at the moment, what the evidence is showing us in terms of people who've evaluated these RAG tools is that they have this type of complementary role to the traditional searches. They're not going to replace, at this stage, the searches that we currently do to inform systematic reviews. So the challenges of the RAG tools are that they are searching large public collections of bibliographic records. So they are usually searching Semantic Scholar or Lens, and often they're searching PubMed as well. But what they don't provide access to is the information in the large subscription databases, which are currently behind paywalls. They vary in their ability to also search the web to find grey literature. So some of them will go away and also do a web search, but most of them are searching these large collections of literature. So they're offering a partial access to the information we need. So it's highly likely that the information coming back will typically be reaching those 75% levels of recall that we see in a lot of the published evaluations. The search processes they're using and the record selection processes they're using are usually not clear to us. It's a bit black box. It's very black box. They also have a range of unknown biases because we don't know how they're selecting the records that they choose to show us at the end. And knowing that, it means we have to think about options to reduce the bias that might be there. So we probably need to search using more than one question. There are also many RAG tools, and it's hard to decide which one is best. And most do broadly the same thing. They search Semantic Scholar using various techniques. They bring the results back, and they then summarize them. The ones that I think, from my own personal perspective, are most useful are Aster, because it gives me the papers and doesn't go on to do the summaries, and also SciSpace, because it has various tools that help us with the search, in particular a topic assessment. There are various evaluations of some of these tools. This one is by Cassandra Gorton, and she's looked at a range of tools, and she's come up with a ranking, a scoring and a ranking process. And what you have here is her view that of these tools that she assessed, the most useful she felt were Consensus and Evidence Hunt, and then Elicit and Litmaps. And I've highlighted the ones that are RAG tools rather than the underlying data collection. So Lens, Semantic Scholar and OpenAlex are record information collections. They're not AI tools, whereas Consensus, Evidence Hunt, Elicit and Litmaps are AI tools. Aronte is keeping a regular eye open for what he calls academic search engines, which are these RAG tools. And you can see here from his diagram that he's got various tools that I've already mentioned, like Elicit and Consensus. So I mentioned that Aster is my favorite at the moment, and it's mostly my favorite because it's searching not just abstracts, but also has access to 12 million full text papers. So this is making it a richer source of for searching, because you have access to all that full text information as well within Semantic Scholar. And also it's useful because it doesn't then go on to do the summarization process, which just takes time, where I'm really interested in the papers and analyzing the papers to help me with my search development. So I'm not going to go into any more detail, but really just to show that Aster does describe what it's doing, but it's not a transparent process. And what you can see here is also the amount of information it gives you about the papers is quite helpful. So it will give you snippets from the papers that give you a sense of the relevance of the paper to your question, and it grades the papers by its own relevance assessment and criteria. I also mentioned that I like SciSpace. Now, SciSpace is searching Semantic Scholar, OpenAlex, Google Scholar, and other resources. So that makes it, as a tool, it's searching a wider range of resources than many others. And it also gives you flexibility in its display options. So if, for example, you wanted to look at particular aspects of records, such as the outcomes or the results field, you can specify that in the display options. It also offers you additional prompts. So it will say there are other ways you can ask the question you've asked, and those rewordings are quite useful because it means you can then use those to get different information out to help us reduce the biases that I've mentioned just earlier. It also has the Find Topics option, which is very useful again for helping you to think about the concepts that might be involved in your search. It also has a range of deep search agents, which means it links up to other resources such as Prospero, which is a database of systematic review protocols, and enables you to search those as well. So SciSpace is quite a fully featured tool that I think is useful for a range of options in search strategy design. So this is just showing you the search results, and at the bottom you can see the tables that it develops, which can be helpful for being able to focus in on particular aspects of the record to help you pick out terms for search development. And these are the search agents that it's offering at the moment. So you can see it's accessing public resources such as Agris and others. So if you've not come across this before, you might want to explore this from the nursing perspective. I'm not going to talk in detail about some of the other tools, but I just wanted to highlight ones that seem useful. As I've said, Aster and SciSpace are the ones that I think are most useful and have the most elements of that will help. But I just wanted to mention Consensus and Undermined. Undermined is useful because it's searching preprints. Elicit, which lots of people value because it's searching Semantic Scholar, PubMed, and clinicaltrials.gov. I just wanted to highlight now how we should think about using and reporting AI and AI tools. It's really important to read the methods guidance of the systematic review body that you're producing your review for example, Cochrane or JBI, because there is guidance now for how you should select and use the AI tools and how you should report your use of the AI tools. So it's probably not going to be acceptable to only use AI for your searching. You're going to be criticised, I suspect, if you only rely on AI. So the use of AI tools needs to be justified. And at the moment, I think the recommendations are it should be used as a complementary approach in addition to the traditional searches. And it's really important that we don't submit hallucinated references as a result of searching. So we need to be sure that the tools we use are those that are as unlikely as possible to produce hallucinations. I'm going to move on just to highlight that there are a range of ways to evaluate AI tools. And the real time-consuming challenge of us identifying and using AI tools is in evaluating their usefulness. So we have various forms of evaluation. We have personal assessments and we have research-based assessments. I've given you some of my personal assessments today. Aaron Tay gives personal assessments in his blogs, and there are other people writing blogs that also give personal assessments. But ideally what we want for evaluations are research-based assessments, where we've got people conducting research, protocol-driven research, using methods that compare retrieval of these new tools against either gold standards from published research or by parallel research lines, by the new technique being compared at the same time as we're doing traditional searches. So the approach that most people are using when they're evaluating tools at the moment is the relative recall approach. And I just wanted to highlight that relative recall is a very useful approach for evaluation, but it does have the weakness that the quality of the quality of the searches for the original reviews are often very poor. So when people are measuring the performance of an AI tool against search strategies that people have developed, it's really important that the search strategies used in those original searches were well conducted. Otherwise, the true measure of the AI performance may not be being measured. And we need more test validation collections of well-conducted systematic reviews with well-conducted searches. The prospective studies I've mentioned involve the evaluation of the new method in parallel to the traditional method. And you can see examples of these types of research being undertaken. And what's really important in those tools is making sure that the formal assessment is fair for both arms of the study. And it might well be that we need independent third-party judgments of the quality of the strategies delivered. And the following slides just highlight some of the evaluation tools that people are using in practice. You've seen this one already. This is the Monash University tool that is quite high level but has this scoring process. The Haraskama paper is an evaluation of 8 AI tools and uses a range of aspects of the tools to evaluate them, but also incorporates published the evaluations are from also includes published evaluations to inform their overall assessment. Gottlieb Malkowska has a quality assessment tool for ChatGPT generated Boolean search queries. Again, there is a scoring process here, but the tool itself looks at presence, absence of features rather than the quality of what's going on. So I think this probably might need a bit more work, because it's not clear that the quality of the query is being assessed in the same way as the presence of features. A more detailed assessment tool is provided by Robin Painter and colleagues. This starts to get quite granular, quite in-depth. And then Canada's Drug Agency have published a very detailed evaluation tool, which is recommended by Cochrane and JBI as an example of a tool that should be used to develop AI search tools. But it does require, I think, quite a lot of technical knowledge to complete. And that's why I've highlighted that first attribute, compliance. And this is an example, a screenshot of a sort of worked up evaluation form for the Canada's Drug Agency tool. And just wanted to finally mention the RAISE guidance. This is that RAISE is the RAISE guidance has been developed and endorsed by a range of major systematic review organisations, including Cochrane, Campbell and the JBI. And RAISE is all about the use of AI in evidence synthesis, and it contains the most recent version of the RAISE guidance, which was published in November, has detailed guidance on evaluating AI tools, recommending the use of that Canada Drug Agency tool, provides a template for reporting on how AI tools were developed, validated, and provides a very detailed example of what it calls a completed responsible handover tool. And what this is a tool that RAISE is encouraging people who develop AI tools to complete. So if AI tool developers and methodologists are able to provide these handover tools, it will make our life choosing which AI tool to use much easier, because the publishers and the evaluators will have given us very detailed information about what the tool does and how it works and what its performance levels are. So hopefully, if people take up on board the responsible handover framework, we will be, as users, we will get far more detailed information about the usefulness of the tools. So finally, just some thoughts on keeping up to date. These are all on my little website. So important to be aware of the guidance from the key evidence synthesis organisations, particularly the ones that we are providing the evidence synthesis for. So just some of the organisations involved here. There is a wiki being regularly updated by Dean Giustini, and this is very useful for lots of new developments in AI search tools, and he's now providing pages for many of the RAG tools that I've mentioned with regular information about evaluations as they get published. So an incredibly useful wiki to keep your eye on. The bibliographic literature is being screened by the team that produces, Farhad Shakraneh and his team, providing the living evidence map for automation of systematic reviews. This is a free bibliography, basically, of new publications around AI in the use of systematic reviews. and it looks at all of the parts of the evidence synthesis process, but it also has also looks at searching. And then there is the systematic review toolbox, which again is about all aspects of the systematic review process, but does also include new tools in searching. And there are other resources that I've listed there as well, but they may be slightly not being kept up to date quite as frequently as the two that I've highlighted. Very interesting and cutting edge information on search perspectives or using on search perspectives of AI in search, provided by Aaron Tay. He's got his list of search engines, and then he writes a regular blog on the Substack link there. And obviously the place where we'll get the most up-to-date information is conferences and meetings. So being aware of and scanning their proceedings, the proceedings of organisations like the ones I've listed here would be very useful. So just to sum up, we're still waiting, I think, for tools, AI tools, which will generate search strategies in full. There are some promising tools and developments, but none of them generate search strategies like we can. They're still prone to error, very much focused on PubMed and so on. There are chatbots linked to databases, and these are improving rapidly, but currently produce strategies that you need to be an expert to assess whether they're actually as useful as they could be. There are these research discovery tools that can help us with identifying relevant studies to help us then identify search terms to use in strategies, and that can help us to identify concepts in the literature. And what we really need is formal independent evaluations of tools to help us make informed decisions about their usefulness. And obviously this is very challenging in the context of constant evolution that we're currently in. Nothing is standing still and things are developing incredibly rapidly. But there are very good resources that will help to keep us up to date with all these developments, and I hope that you've seen some of these today.
Great, Julie, thanks so much for doing a deep dive into AI for literature searching, because as it's such a technical area, it's great that there's more tools being developed, even though they're not perfect. But it'll be interesting to see how quickly they develop and where we'll end up in maybe even 12 months' time. Who knows? It could be all automated.
Absolutely.
Great. Lovely. I think you actually answered all my questions that I had as you were going along. So, and the summary at the end was really helpful. I suppose, yeah, my only real question is, where do you think it's going to go? Because it's so difficult to kind of predict how quickly it'll develop.
I think one of the issues that seems to be happening at the moment is that what we would hope is that we'd have ChatGPT type connectors to some of the pay databases. So I imagine that's what we'll see, so that people who've got subscriptions to databases behind paywalls will be able to use ChatGPT to access them via some sort of permission process. So that would be really great. But I think what we really need is somebody to devote some time training the chatbots to actually search better or to develop searches better. And I don't know how that will happen or if that will happen. But we are also seeing some publishers removing their records from the publicly accessible collections. So that will be interesting to watch as well, because so many of these discovery tools are surviving on the free information. And if that starts to shrink rather than grow, I guess their future will be curtailed, and unless they can also find ways to give people better access to the paid for information.
some useful things to think about for the future. Well, thank you so much for your time, and hopefully we'll check back in with you in another year or two and see where we're at.
Okay, thank you, Siobhán.
Thanks, Julie.